Alright guys, so how old is Jupiter's Great Red Spot? Well, as you're going to find out, the answer is not very clear because like almost everything else, astronomers don't have any idea what they're talking about. Also, if you're a teenager with a huge acne problem, make sure you continue watching this video because you're going to see that your problems with your face are nothing compared to Jupiter's issues. So let's have a look here. Observations from 1665 to 1713 are believed to be of the same storm. If this is correct, it has existed for at least 356 years. So this Great Red Spot may have existed before 1665. However, there's another theory because the Great Red Spot may have existed since before 1665, but it could also be the case that the present spot was first seen only in 1830. Why is that? That's because between 1713 and 1831, there was no observations made of the Great Red Spot. So the one seen in the 17th and 18th centuries may have disappeared. And the one first observed in 1831 may be a different one. So the Great Red Spot is often credited to Robert Hooke, who described the spot on the planet in May of 1664. So why does it say 1664 here and above at the top it says 1665? That's because another observation was made by another astronomer, Giovanni Cassini, in 1665, and supposedly his observation was more convincing. So what was wrong with Robert Hooke's observation? Well, the main problem was he said it happened in the North Equatorial Belt as opposed to where we see it today in the south, or where the Cassini's observation in 1665 was in the south and the ones after that up until 1713 were in the southern hemisphere of Jupiter. But I have a theory that Hooke may have seen the same spot. Now think about this. Hooke saw his in 1664 and Cassini saw his just a year later. So what are the odds that they were two different storms that they saw? Given that the technology back then wasn't that great, these telescopes were the first or second generation of telescopes, they weren't that clear. So it's very likely that it was the same spot. So why the issue with the location? It could be a simple error. Now, here's something you may not know about telescopes. Now, here's an article here. The question asked here is, why does my telescope view upside down and what can you do? So, the way lenses work is the image is always upside down. If you have bought a new telescope and set it up and you've looked through the lens, you might be surprised to see objects in space appear upside down. Lots of astronomers experience this. So why does my telescope... This is actually normal and it does not mean your telescope is broke. The truth is not all telescopes will show images upside down. So you can get telescopes that view it the right side up. It depends on how it's designed. But basically, some telescopes view the images upside down. So it could be that this is a really simple oversight. And if you think that like scientists wouldn't make an easy mistake like that, think again. Scientists make lots of mistakes. And if you want to see other examples, be sure to subscribe to this channel because there's nothing I love more than proving scientists wrong, especially the really arrogant ones. So it could be that it was just a simple oversight by Hooke. Who knows? The Great Red Spot has been observed since 1831. So this sentence kind of leans towards the idea that this Great Red Spot was a new one. By 1879, over 60 observations were recorded. So between these years here, 60 observations, not that many really over this long period of time, 48 years. So after it came into prominence in 1879, it has been under continuous observation. So we're pretty sure that the 1831 observation is the one we see today. So what's the situation now? What's happening with the Great Red Spot? Is it shrinking? Is it getting larger? Well, according to this, it's actually shrinking. The shrinking and flaking fueled from concern from some astronomers that the Great Red Spot could dissipate within 20 years. So this word is interesting here, concern. So why would you be concerned about a storm on another planet? These astronomers, they're sentimental, they're romantic. They have an emotional attachment to this Great Red Storm, and they're concerned that the Great Red Storm could dissipate and no longer exist. So I want to go back a second to this 118-year gap. Now, some of you might be asking the question, maybe the spot moved to the far side of the planet, and that's why we didn't see it for 118 years. But this is not the case, because the time to rotate 9 hours 50 minutes. So basically Jupiter's day is less than 10 hours. So it takes Jupiter less than 10 hours to rotate on its own axis. Now the Great Red Spot doesn't rotate at the same time. It actually takes 6 Earth days or 14 Jovian days. So it takes it 14 times longer to do one rotation than Jupiter itself. But as far as we're concerned, it's 6 Earth days. So this is the important one for our observations. It means that every 6 days it does a full rotation. So every 6 days you will see the Great Red Spot in the same location. Basically, you'll have 3 days where you can see the red spot, and then 3 days where it's at the other side. That argument can be debunked right away. So again, I think the reason of the 118-year gap is because they're two different spots. And this new one formed sometime before 1831. But probably it might have taken, who knows, 5, 10, 15, 20 years to form. Now, it could be that it had already formed before that, but it was a different color. Which leads to my next section here. So here we can see a clear, vivid red color here. Here again, this was taken by Pioneer 1 in 1974, a clear red spot. But if we look at this one here, we can see it's a lot paler. It's more of a slight pinkish color here, a very light red color. So the color fluctuates from like a deep red to like a white color almost. Now this could explain the gap as well. So maybe that was the reason. But the red spot has, you can see this fluctuation happen over the course of years rather than like decades or over a century. Here's an article about the shrinking. So this is a video, and you can see the outline of the red spot here, and you can see the dotted black line that was put in to show you how big it was previously. So we can see how much it shrank. It's also getting taller. So it's shrinking and getting taller at the same time. So what's going on here? So it explains here, and he uses a pretty good analogy. Instead of spinning faster, the storm appears to be forced to stretch up. So the analogy he uses a potter making clay objects. So it's almost like clay being shaped on a potter's wheel. As the wheel spins, an artist can transform a short, round lump into a tall, thin vase by pushing inwards with his hands. So basically, like you make a vase, it gets thinner and thinner, but it gets taller and taller. And they believe this is what's happening with the storm. Those of you who are sad that this Great Red Spot might be coming to a slow end, don't worry, because we actually have some new spots, some new red spots. So this article from 2008 describes the little red spot. Jupiter's little red spot, it became known as. And it's just talking about it here. So this fearsome storm has been growing since 1998 with the merger of 3 smaller white storms that had been observed since the 1930s. 2 of these storms coalesced in 1998, and the combined pair emerged with a third major storm in 2000. So this little red spot formed from 3 so-called white storms. Now, I'm going to show you this image here from Voyager 1 in 1979. Now, I believe this is the one they're talking about. This white storm underneath the Great Red Spot. And in 1998, it merged with another one, which might be this one. Or it could be this one here. This one is less circular in shape. And you can see there's one here as well. And there's another one there. So I'm not sure if any of these or even one of these are the ones they're talking about, but it looks like this one's pretty huge. So it could be this one merged with another one in 1998, and this could be the one they're talking about. And it kind of changes its color. You can see a reddish color here. So this little red spot, and I think we have some more pictures here of this. Here we go. This is in April 2017, and it looks like this is probably it here. And you can see this white one here as well. So I don't think these ones are close enough. So if we look at the bands of Jupiter, see how it goes east to west bands. So we can see this band here. If this moves across here, it's like just underneath the Great Red Spot. So it does seem to me like it might have been this is the same one. And even though it looks pretty close here, they're in different bands. And so it's not interfering with the Great Red Spot. And so it may merge with this one here. You never know. This little red spot could get bigger if it merges with this one. And if the Great Red Spot is shrinking and it finally dissipates, this little red spot could take its place and be like the new Great Red Spot. And this is what could have happened in the 17th century, that there was another Great Red Spot somewhere in the southern hemisphere, and like it seems with the Great Red Spot that we know today, that could have disappeared, and then this Great Red Spot that we know could have formed before 1831. And so it just seems like it's a cycle here, that these Great Red Spots form and then they dissipate. And I have even more good news for you guys, because apparently there's another red spot. Now this is another picture. So this is the same little red spot. Now look at the color here. It's white. And this was taken in 2017. And it's in the southern hemisphere. So this is the little red spot, and it's white. It's no longer living up to its name of the little red spot. So we can see how the color changes. It was like white storms merging, forming a red storm. Then it changes to white again. And with the Great Red Spot that we know, we've just shown you that it gets paler and then gets darker red over time. And so we have another little red spot. So this article here talks about another little red spot. So this is the third red spot. So we have the Great Red Spot, we have the little red spot further south, and this one is in the northern hemisphere. So this image is kind of upside down, you could say. So the North Pole is roughly here in Jupiter, so it's pretty far north. And here we go. The view of the high north temperature latitudes. So this is the technical name for all these letters. This is the third largest anticyclone reddish oval on the planet. And this one, I'm not sure if it's the same one, but here, this article, now this image, I think it got touched up a bit. This is it here. This is high in the northern hemisphere. So it's over Jupiter's northern polar region, and it's named North Temperate Little Red Spot 1. And here it is here. So there's bad news and good news. So the Great Red Spot that we know looks like it might disappear in the next 20 odd years. But the good news is that we're seeing at least 2 more red spots formed, and they seem to be forming from these smaller white spots. And then they get to a certain size and then they turn red, and then it goes back between kind of red and white. This is Jupiter. Jupiter is not a static planet. You can see this animation here. You can see all these bands, and they seem to be going at different speeds and different directions. There's the red spot there. But you have all these white ones. Look at, there's so many white spots. And even here, you can see a little red spot here in this band and another one here. So this band here to the north, this is pretty close to the equator of Jupiter, I think. You can see all these red ones, and maybe these red ones will merge into another massive red one. So really exciting stuff. Again, for those teenagers with spotty faces, well, your spotty face is nothing compared to these red spots. And like this is larger than planet Earth. Earth is about the same size as the red spot. Now the red spot was a lot bigger than Earth before. And that's what we're talking about here. So let's see how it develops. And the good thing is that now the instruments are much better. We have way more people observing them. We got hundreds or thousands of telescopes all across the planet. We got amateur astronomers. We got professionals. We got all the Hubble Space Telescope and all these space probes. And so we're going to learn a lot more about these red spots in the future. But for now, just accept that astronomers, their lack of knowledge really could fill the entire universe, like literally. That's it. See you guys next time. Goodbye for now.